Number 32 is about terpenes, which are a part of the lipids chapter from the new material. So this question asks you to draw a mechanism explaining how this structure here becomes this structure here. So the first thing to know about these reactions is whenever you see OPP, all OPP is a good leaving group. So like H2O positive or chlorine, it wants to pop off, and that carbon it's attached to becomes either positive or partial positive before it leaves. So something is going to be inclined to attack that carbon there. Now, what the answer key shows and what I would want to do are kind of two different things, and I'm going to address both of them. First, I'm going to draw my way because it takes a fewer steps, and this is the way I originally learned this back in 2013. So forgive me if I'm a little dated. Basically, if this OPP wants to pop off, well, let's consider what I'm trying to do. I'm trying to make a 6-membered ring. And so this methyl over here I could number as 1 because that's probably this carbon with the methyl over there. And then 2, 3, 4, 5, and 6. Well, here must be 2, 3, and 4. And that must be connecting to, well, these carbons are the same. So this over here must be 5, and this must be 6. So my first thought would be, okay, well, how can I get 4 to attack 5? Carbon 4 is on a double bond whose electrons could be used to make that connection. So these electrons could go out and attack carbon 5 like that. And that would give me the 6-membered ring because this carbon right here, carbon 4, would attach to carbon 5 while kicking the OPP out. And so now you would have the methyl, the 6-membered ring, this carbon over here, and a double bond like that. Now keep in mind, if this double bond is using its electrons to attack here, well, 4 makes a new bond, but this carbon over here, let's number it 7. 7 loses the double bond and gets nothing in return. So 7 is going to now be positive. And so I'm almost there because I have this double bond in the right spot. I just need to make a new double bond over here. And now how do you make a double bond when there's a positive charge involved? Well, this is one end of the double bond. That's that carbon over here. I need to make the other end over there. Notice the hydrogen count. This has 2 hydrogens, and right now this carbon has 3. So all you're going to do is a simple elimination reaction. Your base, whatever it may be, it's a biological system, so there's usually water involved because this is a synthesis that goes on in the body for fats. That water will grab a proton, the electrons swing down, and in those few arrows, I get the product. So that would be the way I was taught how to do it. But now let's go through the way that the answer key has it and explain or question what they did. I think for me it's more a question of what they did than explaining it. So what they did was rather than have the double bond just form the ring right away, what they did was they chose to say, well, OPP's got to leave. That's still true. But what's going to happen instead is this double bond will resonate with it and you'll end up getting a tertiary carbocation. Now this first step can make sense because not every terpene is going to go the way I showed. Sometimes you want to connect carbon 4 to this carbon, and that would justify how you could attack this position. But what I don't understand is now that we've made this, they bring the OPP minus back in and have that attack the positive. And now you have this, an OPP. And now they're saying, okay, now have this double bond attack the carbon you wanted it to attack originally to make that 6-member ring. And in the process, this will resonate over and kick the OPP out. Now the reason I question this is because, well, I already did that in the one step I drew before. And if I do this, well, these 2 arrows right here, this double bond resonating over, this OPP getting kicked out, that's just the reverse of what I did in this first step. So all I'm doing is kind of undoing the first set of arrows I drew. It doesn't make sense to me. It's just an unnecessary set of arrows. But I digress. This is how they drew it. And now this is how they get their 6-member ring. And so I have the double bond there. And now the positive is still in the same place because this double bond is used to connect to that carbon. So this is now positive. And now you're just doing the elimination reaction. You pull off a proton with some base, we'll say water again. Grab that proton, and that electron, those electrons swing up. So I can't give you a good reason why they chose to show it this way in the answer key when I think my way, at least as far as 2013 exams were concerned, was perfectly fine. So you may want to check with the professor on this one because I'm really not sure how to justify this extra set of steps that are basically undoing what you started with.